Okay, so we've been talking about independent and dependent variables, and we looked at that yesterday in tables and graphs. Well, there's a certain way we write the equation to represent that. So if the relationship between x and y is additive, that means we're either adding or subtracting, then we write it y equals x plus b. And this b means whatever we're adding or subtracting. So if it's multiplicative, we write it y equals k times x. And this k is whatever we're multiplying by or dividing by. But one thing to notice is they always start with y equals. And so that is how we have to set up these equations when we determine the rule. So let's look at a few examples. So here we have a table, and it's clearly labeled, so we know what our y is and we know what our x is. So if I look here, I need to figure out what my pattern is or what my rule is. So 1 to 6, I know I can either multiply or add. So if I were to add 5, okay, 1 plus 5 is 6, true. So I try my next one. True, true, true. So my rule here is plus 5. So when I write this, I start with y. Y, it's a very bad y, equals x plus 5. Now, if you're not sure about that, then we can plug it in with some of the numbers here. So if I set just the first one, we have 6 equals, and the x that goes with 6 is 1. 1 plus 5. So that's a true statement. So I know I've written this correctly. And so that's one example of an additive relationship. All right. So this one gives me a clue that it's going to be a multiplicative relationship. Anytime I have 0, 0 for x and y, then I know I'm dealing with multiplication. So 0 times anything is 0. That's not going to help me. Well, 1 times 6 is 6. 2 times 6 is 12. That checks out. 3 times 6 is 18. That checks out. And 4 times 6 is 24. So I know my rule is going to be times 6. And so when we write that, we start with y equals whatever I'm multiplying or dividing by, in this case 6, then x. So if I want to test it out, just to make sure I'm right, I'm going to start with not 0, 0, but I'll start here. So I'm going to say my 6 for y equals 6 times, and my x was 1. So that does check out, so I know I've written my equation correctly. All right. So let's look at this one. The first thing I notice is it's getting smaller. So I'm going 80 to 10, 64 to 8, 40 to 5, and 16 to 2. So it's decreasing. So I know I'm either going to be subtracting or dividing here. Well, if I subtract it, I would have to, for this first one, I'd have to subtract 70. So here, if I subtracted 70, I would have a negative number. So I'm pretty sure it's division. So 8 divided by what is 10? Well, 8. So 64 divided by 8, 40 divided by 8, 16 divided by 8, and these all check out. So the way I can write this, again, I always start with y equals. Y equals, now it doesn't show me how to do it as division necessarily. We've talked all year about how fractions are division. So this would be represented probably by a fraction. And there's two different ways we could do that. We could say y equals x over 8, which would be the same thing as y equals x divided by 8. Or if I divide by 8, it's the same as multiplying by 1/8. So I could also say y equals 1/8 x. They both look different, but they mean the same thing. So here, if I start off, I have 10 for my y equals 80 is my x, 80 over 8. Well, if I reduce this or divided it, remember, top in, bottom out, I'm going to get 10. So it does check out like that. So over here, I did the same thing. I have 80 equals 1/8 times. Now, I'm going to use the dot to represent multiplication instead of the x, since we have the x variable and another x just may be confusing. So for when my y, I wrote that wrong, guys. When my y is 10, my x is 80. Okay, so if I multiply that out, I have 80 over 8, which is the same thing that I had here, which does equal 10. So you could see this represented with either of those equations. They mean the same thing, they just look a little different. All right, one more graph, or table. So this time, if I look, I notice my y is also smaller than my x. But this is not going to be multiplication or division when you look at this. It's pretty obvious. So if I have 7 and I make it 6, I'm going to subtract 1. 6 to make 5, subtract 1. 5 minus 1 is 4, and then 4 minus 1 is 3. So I know that I'm subtracting 1. So again, we write this y equals, and it always starts y equals. Then I have x minus 1. So I want to test this out just to make sure I've written it correctly. So y is 6. 6 equals, my x here was 7. 7 minus 1. Okay, 7 minus 1 is 6. So it does equal out.